Hey guys, today we have a really fun science experiment to do, but first, somebody told me that if I take something heavy and put it in water, then it should sink, and if I take something light, it should float.
What do you think about that, David?
It makes sense. So I have this bowling ball.
It's pretty heavy.
Yep.
Yep.
And this steely. And hopefully we'll be able to see what that person was talking about.
That means that they think this should sink and the steely should float.
Yep.
All right, let's give it a shot.
Okay. I have my steely here, which is the lighter of the two objects, and I have my bowling ball. So according to this idea, this steely should float since it's lighter, and the bowling ball should sink when I put it in this tub of water. So let's check this out.
You having fun there, David? Who would have thought that a bowling ball would float, huh?
Hey.
Obviously, David, that person was wrong. So it doesn't depend on how heavy something is or how light something is. It depends on something else. And that something else is?
Density.
Density. There you go. So what is density? Well, density is a property of matter. What do I mean by that? Well, I mean this. This lemon is matter. And it has certain properties. One of those properties is its density. What are some properties that you can think of for that lemon?
Well, it's yellow, it's round, and if you were close up, you could also see that there are like these little pores in it, little dots everywhere.
Density is also a property of matter. Every object has its own unique density. Every one. You can identify things by their density.
I have two pieces of metal right here. They're both the same size, although one has a slightly different color. And I'm going to put them on these scales that we have right here. And you'll notice that the orange-colored one here has a vastly different weight. It's much heavier than the silver one we have right here. And now I want you to try and figure out on your own, why is this?
Then what makes one object denser than another object?
Well, it has to do with several factors, actually. For example, how big the molecules in each piece of matter are. I have a piece of copper and a piece of aluminum here. Aluminum is number 13 on the periodic table, meaning it has 13 protons within each atom of aluminum, versus the copper, which has 29. That's more than double the amount of protons within each atom of copper, which explains why it is much heavier.
And you can feel that just by holding them, can't you?
Definitely.
All right, so one reason that matter is denser than other matter is because of the size of the atoms themselves. There's a second reason too. And the second reason is how far apart they are. I've got here a piece of pumice, and I also have a piece of aluminum, a bigger piece of aluminum than what David had here. The molecules in here are a lot closer together than the molecules in here, okay? Which makes this denser. So what are the two reasons that certain matter is denser than others? Let's see if you can think of them. So if I was going to find the density of this, if I want to calculate it, David, I'd just find two things. First of all, I find the mass, how heavy it is, okay? I measure that in grams. And the second thing is I find out how much space it takes up. That's called volume. So once I do that, I just take the mass, its heaviness, divided by its volume. That gives me density. It's mass. So our working definition of density is going to be how much mass an object has in a given unit of volume. Say that with me. How much mass an object has in a given unit of volume. and that given unit is a cubic centimeter. Density of water is super important. It's kind of like the criteria for whether something's going to sink or float. So let's find the density of water. All right, I'm going to take this graduate cylinder, place it on my scale here, and it says 30 grams. It's 30 grams right here. Okay. Now I'm going to add 10 milliliters of water. So we're going to add 10 milliliters of water, and it says 40 grams. So let's see, let's do some math here. 40 minus 30 is what? The water weighs 10 grams. All right, now the second thing we have to find out is the volume of water. Well, this is 10 milliliters, and 10 milliliters, when they set the metric system, they determine that every milliliter is 1 cubic centimeter, which is volume. So 10 milliliters of liquid here is really 10 cubic centimeters of volume. So our cubic centimeters is 10. Now we do the formula, we go mass divided by volume. We have 10 divided by 10. So the density of water is 1 gram per cubic centimeter. All right, keep that in mind, 1 gram. Good. Now, what if I did the same thing, and so this time I used rubbing alcohol instead of water? What do you think? Here. And we have 38 grams. So that means that we go 38 minus 30, we have 8 grams. So the mass of this rubbing alcohol is 8 grams this time. What's the volume? Well, the volume is 10 milliliters, so it's still 10 cubic centimeters. So let's do the math. All right, our mass is 8 grams divided by our volume, which is 10. That means 0.8, 0.8. So the density of rubbing alcohol is 0.8 grams, so the density of water is 1. So if I put the two together, which one's going to float on top of the other?
So we have our 10 milliliters of mercury here, and we're going to try and find the density of it. So I have the scale right here, and we already know from my dad's tests that an empty test tube here is 30 grams, so I'm going to put this on the scale, and it is 166. So that means that the mercury inside weighs about 136. So now we can figure out the density of mercury. We know that the volume is 10 milliliters, or 10 cubic centimeters, and we just figured out that the mass is 136 grams. So if we just do some simple division, we can figure out that the density of mercury is around 13, or 13.6. Alright, so I have something really cool to show you with our old friend the Steely here. You remember how when we put it in the water, it sank immediately. Well, the density of our Steely is around 8, meaning it was 8 times denser than the water we put it in. But now we have some mercury right here, and that's density is around 13. So let's see what happens when we put the Steely in the mercury. It actually floats because it's around 1.6 times lighter than the liquid that it's sitting in right now. Pretty cool.
So let's go back to our question of floating, sinking. If it doesn't have to do with how heavy it is, we talked about it has to do with density. So let's do some experiments with that. So this is like this air-filled plastic ball here, okay? You can see how it floats. And this ball here, another ball, this one is a rubber ball. So it's rubber, floats a little different, and let's bring back our lemon here and see how our lemon floats, okay? So if you look at those three, you can see that the lemon is floating a lot lower than this rubber ball, which is floating lower than this air-filled ball right here. What makes an object float at different levels? Well, it's mass, right? It's density. And this kind of reminds me of ships. If a ship is not loaded with cargo, so we have a ship right here. This is our ship. It's going to float pretty high up in the water. And sometimes that creates a problem with balance. And what they have to do is they have these things called ballasts, where they fill with water to help the ship to maintain stability while it's floating. So these would be our ballasts here. You can see what happens when I put these wood blocks on, that this boat floats a lot lower, okay? Now, how low does it float? Here's the answer. Remember we talked about water displacement, how when I put something in the water, the water level rises, it increases, it goes up. That's called water displacement. And this will sink, each of these will sink to the level at which the weight of the water it displaces equals its weight. Let me see that one more time. Okay, each of these has a mass, right? And each of these is going to sink down to the level at which the weight of the water it displaces equals its own weight. And then it stops. Now, if an object, like our Steely here, is heavier, it's not very big. Then the water it displaces, it doesn't displace very much water. So when it goes in, it's a lot heavier than the water it displaces. So it sinks. Obviously, these two have different densities, because when I go ahead and let go, one goes down, one goes up. This one here has a lighter density, helium does, than air, right? So here's the question: how does temperature affect density? How does temperature affect density? So yeah, what I want to do is I want to see if we can make this helium balloon just slightly a little bit denser than air. Okay, so I'm going to put a little piece of plastic on here. And then with the weight of this plastic, you can see that it just goes down. Right now, a little bit heavier than air. Alright, so here's what we're going to do. Take our stove and light our stove. We're going to heat up the balloon and get the air in the balloon, the helium in the balloon, hot. Okay. You can't see the flame, the stove's on. It is on. Let me adjust it a little bit here, because I don't want it too hot. Okay, if I put my hand right here, I can feel the heat, but it's certainly not too hot. And I'm going to go ahead and put our balloon. Remember, it's a little bit heavier right now than the air. And I'm just going to heat this up and see what happens. I want you to watch if you can see anything happening to our balloon. I can hear it. Can you see it filling up? What it looks like. Look at that. So what did temperature do to make that happen? What do you think? Here's my question too. How long is that going to stay up there? What's going on? Why is it coming down now? We're trying to find out how density is affected by temperature. Okay? I think it wants to go up again. There it goes. All right. This is Galileo's thermometer. And here's how it works. We have a liquid inside here, and then we have all these little glass spheres inside here, and they have a little weight attached to them. They're filled with a liquid. And the little tags, the little weights, little pieces of metal, have numbers on them with temperature. This one down here, it says 66 degrees. This one here at the very bottom says 62 degrees. This one here says 70 degrees. This is a thermometer. And so right now, if I had to say what the temperature is here, it'd be about 66 degrees. This one's floating right here. Okay? So again, this works with density. Let's see if we can go ahead and we'll see how temperature affects this. Okay? So I'm going to get a torch here. And we'll see if we can heat this up a little bit and see what happens when we do. What is your guess? If I heat this system up, what's going to happen? And why? Okay? Well, what do you think? They're all at the bottom now. How did temperature do that? Somehow temperature affects density, doesn't it? All right.